some of the most important genes that we're working with today are connected to some serious diseases such as Alzheimer's disease, heart disease, and neurological diseases. And these are some really critical diseases. So DNA testing now is much more affordable. When I started doing it in 2002, it was actually very, very expensive. And if there's any patient in here who paid a lot of money for their Berkeley testing, and now they're paying much less today, you can see how quickly this technology has come down in price. Now, some of the technology that I use actually came out in 1949. It was extremely expensive, and only the government could afford to actually do this research, and it was only available in a research setting. So now we've got nutritional education coming on board, and we've got a public who's demanding more than just pills and surgery. They want to know which diet is going to prevent their heart attack or their Alzheimer's disease or their chronic illness. And now we've got this technology, so we're marrying these two paradigms together, and we're getting amazing outcomes, which we should have been doing a long time ago, but it was not there. Next slide. So anybody familiar with this test, a PKU test? Yeah. This is a test that is actually law. Every baby gets this test in the nursery. And what it is, it's literally a test that tests for a genetic disorder, for an inability to clear a protein called phenylalanine. And if you don't test a child who has this disorder, the outcome is severe mental retardation. And this is why the states made it mandatory that every child should get this, because it's preventable. And the solution is the right diet. And so that is a common genetic test that you're all familiar with. Next slide. So what is a gene? A gene is really literally a blueprint that you have inside of you that says, I have this blueprint and I require a certain environment. And we now know that. We used to think that you've got a certain gene or a certain variation of a gene, then you're out of luck. You're going to probably express that disease, flip a coin, you got the gene, and that's it. We actually know more now. We're a little bit smarter, and we were throwing the protein away that we really should have been looking at in the laboratory. And now we actually are looking at the gene has a genetic blueprint, and we need to match the environment to that genetic blueprint. So now all of a sudden, it's not gene control, it's environmental control, which tells us now that we can all change an outcome of a disease process that potentially could show up in the older part of our lives, such as Alzheimer's disease or heart disease or a neurological disease. Next slide. So the gene that I wrote about, I'm very passionate about, is the APOE gene. It is a very important gene. And for some reason, I think I was away that day in all of the years of the education that I had, I did not remember hearing about this gene. When I came across it, I asked all my colleagues, I said, do you know about this gene? Founded in 1973. Its job is to transport fat and cholesterol in the body. A major job. Nobody that I talked to knew about this gene. I'm like, well, I didn't discover it. Somebody must know about this. Well, Robert Saperko, who founded Berkeley Heart, he actually knew about this gene. So I kind of found him. But it is a gene that literally is able to either transport cholesterol or fat properly or not. So it's kind of got a major job. It was discovered at the Gladstone Institute at UCSF in 1973. It became famous for heart disease first, and then it became famous in 1995 for Alzheimer's disease. And that's when everything kind of broke loose with this gene. It is the most researched gene. So it's pretty exciting. And it is connected to some very serious diseases. Heart disease, Alzheimer's disease, multiple sclerosis. I have seen more research come out in the last 2 years on multiple sclerosis than anything else. I mean, heart disease is still a foundation disease, but multiple sclerosis, we've got some pretty sound information for multiple sclerosis. And serious neurological disease, Parkinson's disease also, with a variant of this APOE gene. All right, next slide. So, an interesting thing about this gene, everybody in this room has it. The question is, which one do you have? And it comes in 3 flavors, if you will. It comes in an APOE2, 3, or 4. In the population, the APOE2 is about 11%, and the APOE3 is about 60 to 65% or so. And then the APO4 is in about a third of the population. Now, the diseases that are connected to these gene types, or these variations of this gene, the APOE2, very, very high cholesterol, a very specific type of high cholesterol, and also Parkinson's disease. The studies are very clear with the APOE2. Clinically, I see ADD in this group, severe ADD in this group. In the APOE3 is where I see most of the diabetics. It is a very sensitive gene balance for fat and cholesterol and protein. And if you don't eat a good diet, balanced diet in this group, you will have some shift in some serious chemistries. In the APOE4, this is where we see the Alzheimer's disease and MS, gout, alcoholism kind of shows up in this group too, and very, very severe arthritis. But if you think about the APOE4, for some reason, this is a gene that doesn't transport properly. The taxi is broken. So if you put an inflammatory diet into the, say, APOE4 person's body that cannot transport it out, then that person becomes much more inflamed than the 2s or the 3s. Now, everybody at some point is going to, they kind of run through McDonald's and do that time-saving behavior, will get the inflammation. But it's not so bad with the 3s and the 2s. The 4s have kind of a unique inflammatory response. But if you think about the diseases that are connected to that, Alzheimer's disease, what is it? It's a neurological inflammatory disease. Heart disease, it's a vascular inflammatory disease. And so each type, now everybody gets 2, one from mom and one from dad, so you end up with a combination. Either you end up with a 2-2, and they're all in my practice, I think, a 2-3, a 3-3, a 4-2, a 4-3, or a 4-4. Now, if you're a 4-4, you actually have approximately 90% chance of Alzheimer's disease. Now, wouldn't you like a solution to that problem? Yes, you would. And wouldn't it be nice if diet would be a really simple solution?
How can you find out which you have, which you have?
How can you find out? How do you get tested? Yeah, you can actually do a test through the blood, or you can do a cheek swab.